to remember this formula. Okay, and next, so next we will look uh, into the effect of the modulation coefficient that I already told you before. So from this figure over here, this is the input, this is the output of the modulator. So the input, you have two input. So if you look at here, this is low signal, low frequency signal. Okay, this one is a high frequency signal. So automatically you should know that this is the modulating signal because it's a low frequency signal and this is a high frequency signal. So you should know that this is actually the carrier signal. Okay, so this is the output. For example, this is the first output. So for example, you look at here, the difference. This one is Vmin is equals to 0. There is no gap. This one you have the gap. Okay. So this is an example if the modulation percentage is equals to 50%. This one is the AM envelope if the modulation percentage is equals to 100%. Okay, so look at here, it can be seen that percent modulation will go to 100% when EM equals to EC. Why? Because M equals to EM over EC. Okay, so if EM is equals to EC, you will get M equals to 1. Okay, and you will get 100% modulation. So at 100% modulation, the minimum amplitude of the amplitude Vmin is equals to 0. Okay, so the maximum percent modulation that can be imposed without causing excessive distortion is 100%. So the maximum is 100%. It cannot go, the percent modulation cannot exceed 100%. If it exceeds 100%, then there will be a distortion. Okay, so next we have another example. Okay, so this example gives you this figure, the output AM envelope. Okay, so at the output AM envelope, you have been given the Vmax and also the Vmin. Okay, so the first question, calculate the peak amplitude of the upper and lower side frequency. Okay, peak amplitude, so you know that this is the amplitude, upper and lower side frequency. So basically, this question asks you to calculate the EUSF and also ELSF. Okay, the amplitude of the upper and lower side frequency. So how to calculate? We just use the formula EUSF. Remember, EUSF is equals to ELSF. The value should be the same. Is equals to 1 over 4 Vmax minus Vmin. Okay, so 1 over 4 Vmax is 18 minus 2. So you should get this equals to peak amplitude of the upper and lower side frequency equals to 4. Okay, correct. 4 volt. Okay. The second one is the peak amplitude of the unmodulated carrier. Okay, this is the amplitude of the carrier. So basically the question asks you to calculate EC. Okay. So B EC. So EC is equals to 1 over 2 1 over 2 V max minus V min. Okay, sorry, EC is 1 over 2 V max plus V min. Okay, so this is 1 over 2, 18 plus 2. Okay, so the answer is 10 volt, correct. Okay. And C is the question asks you to find the peak change in the amplitude of the envelope. So what is means by peak change in the amplitude of the AM envelope? Okay, so this question actually asks you to calculate for the EM. Okay, EM we also call it as the peak change of the amplitude of the AM envelope, because this is EM. Okay, so it is the peak change of the amplitude of the AM envelope. So C is EM. So EM is equals to 1 over 2 V max minus V min. Okay, so this one don't get confused between EC and EM. This is plus, this is minus. So you put in the values, you should get the answer equals to 8. Okay. Okay, correct. 8 volt. Okay. And then D, coefficient modulation is M, small m. Okay, so please calculate for coefficient modulation. M equals to EM over EC. EM is 8, EC is 10, so you should get equals to 0.8. Huh? 0.4? 0.8. Okay, so the answer is 0.8. Okay. No unit, because this is coefficient modulation. Okay. And the last one is percent modulation. Percent modulation is capital M. So it is actually modulation coefficient multiplied with 100%. So you should get this equals to 80%. Okay. So any question for this example?
No.
No. Okay. So I hope that you guys understand. This is basically simple calculation. Okay. But you need to remember the formula. You need to use the correct formula. Okay. So next, we will proceed to subchapter 2.4, AM voltage distribution and analysis. Okay, so this one, for this slide, okay, given the unmodulated carrier signal, okay, equation 9, this is actually the carrier signal VC, VCT. Okay, so VCT is actually EC sine 2 pi FCT. Okay, so this is equation 9. So based on, this is the characteristic of AM wave. Okay, you can see that the repetition rate of AM envelope is equal to the frequency of the modulating signal. Okay, so the AM envelope, it follows the frequency of the modulating signal, and the amplitude of the AM wave is proportional to the amplitude of the modulating signal. Okay, and it also stated that the maximum amplitude of the modulated wave is equals to EC plus EM. Okay, because you already know that Vmax is equals to EC plus EM. Okay, so next, what about the equation for the modulated signal, the output? Okay, so the output modulated wave can be expressed as VAMT. Okay, so this VAMT is equals to EC plus EM sine 2 pi FMT multiplied with sine 2 pi FCT. Okay, so this is equation 11. This is the formula, the equation for the output modulated wave VAMT. Okay, so this one, the VAMT, this is the AM envelope. Okay, so this is the equation for the AM envelope. Okay, equation for the AM envelope. So if you look at here, okay, this is the amplitude. Look at here, this is the amplitude. So you know that this is EC from 0 to this point, this is EC. From this point to here, this is EM. That's why Vmax is equals to EC plus EM. So you look at here, the amplitude of this modulated wave is equals to EC plus EM. And the frequency is sine 2 pi FMT multiplied with sine 2 pi FCT. Okay. So if the question asks you to give the expression for VAMT, then you need to give this equation with the value inside. Okay, with the value for the EC, EM, FM, and FC. But usually, if the question asks you to give the expression for VAMT, instead of we give this equation, we usually gives VAMT equation in terms of frequency spectrum instead. We rarely give the VAMT in terms of AM envelope. Okay, so what is the VAMT expression in terms of frequency spectrum? So that one you can refer in slide 19. Okay, so this is the expression for the VAMT in terms of frequency spectrum. Okay, so if you want to know the derivation, then you can refer to this slide. Okay, this slide already show you the derivation from equation 11. Then you will get this equation. Okay, so this is the VAMT expression based on frequency spectrum. And this one you must remember. Okay, and this is very easy to remember actually. Okay, VAMT equals to EC sine 2 pi FCT MEC over 2 cos 2 pi FC minus FMT minus MEC over 2 cos 2 pi FC plus FMT. So why do I say that this is quite easy to remember? Because if you can remember this frequency spectrum, you know that this is FC, you know that this is lower side frequency, this is upper side frequency, then you can come up with this expression. Okay, so look at here, you have three signal, 1, 2, 3. So in this equation, you also have three signal, 1, 2, 3. Okay, so the first signal is the carrier signal in the middle here. So look at here, this is EC sine 2 pi FCT. Okay, this is the carrier signal. The second signal, we have the lower side frequency. Okay, so this one, look at here, the amplitude VLSF is equals to MEC over 2. Okay, so if you want to calculate VLSF, you can use this formula, MEC over 2. Cos 2 pi Fc minus Fm. So you know that lower side frequency is this part here. This is Fc minus Fm. This one is Fc plus Fm. Okay. The third one here, this is MEC over 2, the amplitude. And the frequency is Fc plus Fm. Okay. And you must make sure that for the lower side frequency, this one is at, this is minus. Okay. So quite easy to remember this one. You must remember. So if the question asks you to give the VMT expression, you must give the expression together with the value. Okay, EC, FC, this value, FC minus FM, this value, the amplitude for the VUSF and VLSF, and also FC plus FM. Okay. Okay, so next from equation 15, okay, the previous equation for the VAMT, there are few characteristics that can be deduced. Okay, so the first one is stated that the amplitude of the carrier signal is unaffected. Okay, so the amplitude of the carrier signal is unaffected because you have something like this. This is the carrier signal, and the carrier signal is unaffected by the modulation process. Okay, it remains as EC. Okay, the second one, the amplitude of the upper side frequency and lower side frequency depends on both the carrier amplitude and the coefficient modulation, because you know that EUSF is equals to MEC over 2. So that's why it's stated that the upper side frequency and the lower side frequency depends on both the carrier amplitude and also the coefficient modulation. And over here, stated that for 100% modulation, where M equals to 1, okay, if you calculate for the Vmax, you will get Vmax equals to 2 EC, okay, and the Vmin will become 0. So why 2 EC? Because you know that Vmax is equals to EC plus EM, okay. So EM is USF plus ELSF, okay. USF because USF is MEC over 2, and now M is equals to 1, so it will become EC over 2, okay. So EC plus EC over 2 plus EC over 2, you will get 2 EC. Same for the Vmin, okay. Okay, so next we have another example. Okay, so one input to the conventional AM modulator is a 500 kHz carrier with an amplitude of 20 Vpeak. The second input is a 10 kHz modulating signal that is of sufficient amplitude to cause a change in the output wave of 7.5 Vpeak. Okay, so firstly, you need to understand the statement here. So given here, you have 500 kHz carrier. So Hertz, this is frequency. Carrier is FC. So FC is 500 kHz. Okay, don't get confused. Okay, if it's Hertz, the unit is Hertz, then it is frequency. Okay, sometimes student put VC is equals to 500 kilohertz. Okay, this is basic. Hertz is frequency. Okay, and this one the amplitude of 20 V peak. Okay, so we actually this word, this sentence over here actually explain on the carrier. So you should know that this is actually the EC. Okay, so EC is equals to 20 volt. Okay, the second input is a 10 kilohertz modulating signal. So this one you know that FM is equals to 10 kilohertz, and that is sufficient amplitude to cause a change in the output wave of plus minus 7.5 V peak. So this is the EM. So EM is equals to 7.5 volt. Determine the upper and lower side frequency. Okay, so try and calculate this one. This is frequency. So basically the question asks you to find FUSF. FUSF is FC plus FM. FLSF is FC minus FM. Okay, so the answer is answer FC plus FM. FC is 500K, FM is 10K.
$510 kilohertz.
510. So lower side frequency?
490
490 kilohertz. Okay, so this one is 5110. This one is 490 kilohertz. Okay. Next is modulation coefficient and percent modulation. Okay, so modulation coefficient is EM over EC. Okay, EM, very simple, EM 7.5 divided by 20, you should get 0.375. Okay, percent modulation is M equals to M multiplied with 100%. Sorry, 100%. Okay, so you should get 37.5%. Okay, C. Try and calculate C. Peak amplitude of the modulated carrier and also the upper and lower side frequency voltages. The upper and lower side frequency voltages, okay, don't get confused. This, even though this statement is have the frequency and the voltage, the question actually asks you the voltage, okay, upper and lower side frequency voltages, the amplitude for the upper and lower side frequency. So this one is actually the EUSF and also ELSF. Okay, so EUSF and ELSF, you can use the formula because you have the M, you have the EC, then you can use the formula M EC over 2. Okay. So MEC over 2, this is 0.375 multiply with 20 divide by 2. So you will get this one is 3.75. Okay, so I want you to give me the answer for this one. Peak amplitude of the modulated carrier. Anyone can answer what is the value for the peak amplitude of the modulated carrier? Tahu tak how to calculate for the peak amplitude of the modulated carrier? Okay, so since tak ada yang there's no response, so I think that you guys didn't know how to get the value for the peak amplitude of the modulated carrier. So this one, the value here, this is the carrier. Okay, however, this is the carrier at the input. Okay, when we talk about modulated carrier, this is the carrier at the output. Okay, so remember that the carrier doesn't change. Okay, so basically the carrier at the input is equals to the carrier at the output. So basically the value for the peak amplitude for the modulated carrier is the same as EC. Okay, so for C over here, the answer is actually EC modulated is equals to EC unmodulated. Okay, nampak faham this is unmodulated, this is modulated. Okay, so it is the same, which is equals to 20. Unmodulated before the modulation process. Modulated is after the modulation process. And the maximum and minimum amplitude of the envelope, this is Vmax and Vmin. Try and calculate for Vmax and Vmin. Okay, so please calculate for Vmax and Vmin. So it is quite hard for me to write it here. So I hope that you can calculate it by yourself. So Vmax, Vmin. Okay. Vmax is EC plus EM. Vmin is EC minus EM. Okay, so give me the value for Vmax and Vmin.
uh, 27.5 volt.
Okay, so that one is Vmax. Vmin?
12.5 volt.
Vmin is 12.5. Okay, so thank you. So Vmax is 27.5. Vmin is 12.5. Okay. Okay. Okay, the question asks you to give the expression for the modulated wave. So remember the equation for VAMT? Remember the equation for VAMT. So I want to clear this slide first. Okay, so now let's do E. So E, the question asks you to find the expression for the modulated wave, which is VAM. Okay, so remember VAMT is equals to, the first one is the carrier signal. So it is EC sine 2 pi FCT. And then we have the lower side frequency. So MEC over 2 cos 2 pi FC minus FM T. And then we have the upper side frequency MEC over 2 pi FC plus FM T. Okay, so this one you cannot leave it like this. You must put in the values. So all of these values already been given in the question, and also you already calculated in question A, B, C, D. Okay, so just put in the values. So the final expression for VMT you should get EC is 20. So 20 sine 2 pi FC is 500K T plus MEC over 2. This is ELSF. So you already calculated. The answer is 3.75. So 3.75 cos 2 pi. Okay, FC minus FM, you should get 490. Okay, T. Minus MEC over 2 is 3.75. 2 pi. Sorry, this is you have cos. Cos 2 pi. FC plus FM is 510. Okay. Okay, so this is the answer for E. And for F, draw the output spectrum. So this is your output spectrum. So the first signal here, this is the carrier signal. So the amplitude is 20. Look at here, the amplitude is 20. So EC is equals to 20. This one is E LSF equals to 3.75. Same for the EUSF. This is 3.75. Okay, and the frequency here, this is 500. Okay, this one is 490. And this one is 410. Okay. The unit is Hertz. So this is the output spectrum. Okay, and the last one is the AM envelope. So sketch the AM envelope. So AM envelope, you should get something like this. So previously you already calculate for the coefficient modulation. So the value that you obtain is 0.375, which is not equals to 1. So that's why you don't need to draw the AM envelope. This point here, touch together. Okay, you must draw it like this because the M is not equals to 1. Okay, so this is the AM envelope. So for the AM envelope, the parameter that you can label is the Vmax and also the Vmin. Okay, So your Vmax is 227.5. Okay, you already calculated this, and your Vmin is 12.5. Okay. Okay. So any question for this example?
No, doctor.
Okay, so if no questions, then we proceed to the AM power distribution. Okay, so this one is voltage distribution. So if you look at here, if the frequency you look at the frequency spectrum, the amplitude here, these are all voltage. Okay, but we can also draw the frequency spectrum with the amplitude in terms of power. Okay, so that one will be covered in subchapter 2.5, AM power distribution. Okay, so look at here, PC. PC is the carrier power. Carrier power is equals to you know that V squared over R. Okay, you know that power is V squared over R. However, this one is in terms of RMS, so it becomes 0.707 EC in bracket squared divided by R, which is also equals to EC squared over 2R. Okay, so usually we will use this one. PC is equals to EC squared over 2R. Okay, and also you can calculate for the upper sideband and the lower sideband power. So, okay, this is actually derivation. You can try and derive, but the formula that we use is equation 19. So this equation 19 is, please write this, yeah. PUSB is equals to PLSB is equals to M squared PC over 4. Okay, so the derivation you can refer in the previous slide. So this is the formula that we use to calculate for the upper sideband and the lower sideband power. Okay. And also we can also calculate for the total power PT. Okay, so you have the power spectrum. Okay, remember this is PC, this is PLSB or PLSF, and this is PUSB or PUSF. Okay, so P total is PC plus PLSB plus PUSB. Okay, so for this one, PUSB and PLSB, you already know that it is equals to M squared PC over 4. Okay, so if you calculate PC plus M squared PC over 4 plus M squared PC over 4, so 1 over 4 plus 1 over 4, you will get 1 over 2. So you will get this formula PT. Okay, so P total is equals to PC plus M squared PC over 2. M squared PC over 2 is equals to PUSB plus PLSB. So note that the total power in an envelope increases with modulation M. Okay, so if the modulation, this M increase, then your total power will also increase. And then you can draw the frequency spectrum in terms of power spectrum, in terms of power. Okay, so we also call it as the power spectrum. Okay, so this is the power spectrum. So basically it's just similar to the frequency spectrum in terms of voltage. The difference is that the amplitude. Okay, so the amplitude is in terms of power. Previously it is in terms of voltage, but the frequency here are all the same. This is FC. FLSF is FC minus FM. FUSF still the same, FC plus FM. So the difference is this part here. Okay, so you must remember PC is EC squared over 2R. For PLSF and PUSF is actually M squared PC over 4. Okay. And now let's do the final example. For an AM wave with a peak and modulated carrier voltage VC equals to 10, a load resistance RL is equals to 10 ohm and a modulation coefficient equals to M equals to 1. Determine powers of the carrier and the upper lower sideband. So power of the carrier, of course, this is PC, this is PUSB, and this is PLSB. Okay, so how to calculate? Directly use the formula, very simple. So PC, you know that PC is EC squared over 2R. Okay, so EC is VC, the same. EC is VC. So this is 10 squared divided by 2 multiply with 10. So you should get this equals to 5. While for the PUSB and also the PLSB, okay, this is the same. So this is M squared PC over 4. Your M now is equals to 1. So 1 squared, your PC is 5 divided by 4. So you should get 1.25 watts. Don't forget the unit. This is power, so the unit is watts. Okay, so for the B, this is something new, not really new, but this is total sideband power is not the total power. It is two different things. It is not PT. Total sideband power is PSBT. Okay, total of the sideband power. So PSBT is actually PUSB plus PLSB. Okay, so you can calculate it manually. You just add 1.25 plus 1.25, or you can use the formula M squared PC over 4. Okay, so this one, either one you use, you should get the same value, which is equals to, M squared PC over 2. This is M squared PC over 4. Because 1 over 4 plus 1 over 4, you will get 1 over 2. Okay, so M squared PC over 2, you will get the answer equals to 2.5 watts. Okay, so the total power PT is this one. Total power of the modulated wave. This baru PT. This is PT. So PT is PC plus PUSB plus PLSB. So you can just add manually 5 plus 1.25 plus 1.25. Okay, or PC plus M squared PC over 2. Okay, so you will get this one, you will get equals to, okay, so calculate.
7.5.
7.5. Okay, so this is 7.5 watts. And finally, draw the power spectrum. This is your power spectrum. This is PC. So PC is 5. This is PUSB equals to 1.25. This is PLSB equals to 1.25 watts. Okay, and since this question doesn't give you the frequency, then you don't need to put in the values. You just label it. So this is FC, this is FUSF, this is FLSF. Okay, this is U, this is L, lower side frequency, upper side frequency. But if the question gives you the frequency, you must put the value. Okay, so if not, I will deduct the marks. Okay, because the frequency spectrum is not complete. Okay, and for the question E, you just repeat steps A and D, steps A until D for the modulating index M equals to 0.5. So this one you can try it by yourself. Okay, for the E. Okay, so previously we have covered on the AM voltage distribution. We have this one is AM power distribution. So what about the current? Okay, so we can actually also calculate for the current. Okay, AM current. So if you look at here, the relationship between the carry current and the current of the modulated wave, you can define it like this. This is PT divided by PC, because you want to look at the relationship between the carry current and also the current of the modulated wave. So PT divided by PC. So you know that P is equals to I squared R. Okay, so that's why PT is equals to IT squared R, while for the PC is equals to IC squared R. Okay, this one you can cancel. So you become IT squared divided by IC squared. This part over here comes from, okay, you know that PT is equals to PC plus POSB plus PLSB. And POSB plus PLSB is equals to M squared PC over 2. Okay, so this is PT. So if PT divided by PC, so this will be divided by PC. Okay, so you can cancel. So you will get 1 plus M squared over 2. Okay, so this part over here comes from this here. Okay, so you from this equation 21, you can get IT over IC, and finally you can get the IT total. IT is the I total. Okay, so I total is equals to IC square root 1 plus M squared over 2. So if the question asks you to calculate for the I total, just directly use this formula. Okay, so any question? So basically we have finished chapter 2 part 1. Any question for chapter 2 part 1?
No.
No question so I hope that you guys understand. So chapter 2 part 1 is one of the quite important topic chapter 2 part 1. So chapter 2 part 1 will be covered in your final your test 2 test 1 question 2, and also your final exam, and also your quiz 1. Okay, so your quiz 1 will come from this part, chapter 2 part 1. Okay, so I haven't decided yet when will be your quiz point, so later I will inform you the date for quiz 1. Okay, so for tutorial 1, I hope that you guys already try tutorial 1. I think chapter 1 is quite simple. Okay, so if you have any question for tutorial 1, please you can ask inside the Telegram group. Okay, or you can DM me privately. Okay, and maybe I will discuss some of the question next week if we have the time. Okay, so basically we have finished chapter 2 part 1. This is the syllabus for this week. So basically we have finished the syllabus for this week. So on Thursday we will there will be no class for on Thursday. Okay, so next week we will continue with chapter 2 part 2. Okay, so anything you want to ask before we end our class for today? Another thing, don't forget to and another thing, don't forget to fill in the feedback in the ULearn because I will take that as the attendance together with the attendance from this Microsoft Teams. Okay, so saya akan check dua-dua. So don't forget to fill in the feedbacks and the comments weekly. Okay, so if there is no questions, then I think we can finish our class for today. Thank you very much for your perhatian. Okay, your attention. Okay, thank you.
Thank you, Doctor.
Thank you.
Thank you, Doctor.